Let's take a look how we can use these inverse trig functions to solve right triangle problems and situations. Here's our first example. You have the job of measuring the height of the local water tower. Climbing makes you dizzy, so you decide to do the whole job at ground level. You find that from a point 47.3 meters from the base of the tower, you must look up at an angle of 53.6 degrees. We call that angle of elevation to see the top of the tower. How high is the tower to the nearest tenth of a meter? To set up this problem, I like to identify which pieces of the triangle have been given to me and which piece of the triangle I am attempting to find. So, from our diagram here, we are given an angle theta. We are given the adjacent side, and we are being asked to find the opposite side. So I run through my inventory of trig functions to find the trig function that includes the relationship between the angle, the opposite, and the adjacent. We have two, but the more convenient would be the tangent. So I set up that relationship. Tangent theta equals opposite over adjacent, and I replace each variable with the appropriate values. So tangent 53.6 degrees equals my unknown, I'll call that y since it's a vertical direction, distance, over my adjacent 47.3. Solving for y gives me y equals 47.3 times the tangent of 53.6 degrees. I call up my calculator, double check to make sure I'm in degree mode, and then plug in my numbers. 47.3 times the tangent of 53.6, leaving me with 64.15615.929. Now, I need to put my answer in the correct format according to the question. So the nearest tenth of a meter would tell me the water tower is 64.2 meters high. Here's our next example. A ship is passing through the Strait of Gibraltar. At its closest point of approach, Gibraltar radar determines that the ship is 2,400 meters away. Later, the radar determines that the ship is 2,650 meters away. Here's a picture of the situation. Our question is, by what angle theta did the ship's bearing from Gibraltar change to 3 decimal places? So, in this case, we're being asked about angle theta. We're being given that in our right triangle, the adjacent side is 2,400 meters, and the hypotenuse, in this case, is 2,650 meters. Running through my inventory, the trigonometric function that relates these 3 pieces of information would be, yes, that's right, the cosine. So the cosine of theta is 2,400 over 2,650. To solve for theta, we need to remove the cosine, and we do that by taking the inverse cosine of both sides. So theta would be the inverse cosine of 2,400 over 2,650. So we pull out our trusty calculator, find the ratio 2,400 divided by 2,650, and then ask for the inverse cosine. So here's where we get to use the second cosine of my answer there. and we hit enter, and we get an angle of 25.087 or 088 degrees. If we check our answer, there it is. Our third example uses the same situation from our second example. The ship is still passing through the Strait of Gibraltar. Now we're being asked to the nearest meter, how far did the ship travel between the two observations? So we're given the two distances, the adjacent side and the hypotenuse being 2,650, and we're being asked to find the opposite side. The right triangle relationship between the three sides is simply the Pythagorean theorem, so we set up our Pythagorean theorem with our information, and we say 2650 squared equals 2400 squared plus our opposite squared. So our opposite would then equal the square root of 2650 squared minus 2400 squared. Pull out our trusty calculators again. 2650 squared minus 2400 squared. And take the square root of our answer and hit enter. Rounded to the nearest meter, our answer should be 1,124 meters. To recap, you should be able to answer these questions now. What is an inverse trig function? What information does it supply? Why do the inverse trig functions have restricted domains? What are the domains of the inverse trig functions sine inverse, cosine inverse, and tangent inverse? What is a principal branch? How are the domains of the inverse trig functions determined? How can inverse trig functions help us solve right triangle problems?